Over 7 million people, often living pretty much on top of each other. It's what gives Hong Kong its energy and its edge. But life in tower blocks means a long way up and a long way down.
You do get a little bit of vertigo. But you see everything down below, the restaurant, the art center, and then dozens and dozens of stories leading up to where we are now. 36 floors up in the air. Welcome to vertical Hong Kong.
People are just living their lives up here. There are houseplants.
And the laundry.
From 36 stories up, it's hard to imagine what might happen if there was a fire here. A fire like Grenfell Tower. The deadly West London blaze in 2017 devastated the community and posed a monumental challenge to rescue services.
I was living in London and was commuting by the Grenfell Tower every day. For me, that was a real catastrophe.
Mirko Kovač is a professor of aerial robotics at Imperial College London.
I got a phone call asking us whether we have a drone that can fly inside of the fire and take pictures and check structural damage, check on survivors and so on. And at that time, we didn't have that. The technologies didn't exist that would allow us to fly in those types of extreme hot environments. Since then, that was the nucleus of the idea to create a drone that can operate in extreme hot and extreme cold environments.
Kovač is also head of the Empa Laboratory of Sustainability Robotics in Switzerland. It's a partnership between Imperial College London and the Swiss Federal Laboratories for Materials Science and Technology. The idea is to combine the latest in aerial robotics technology with cutting-edge material science to create a fleet of problem-solving drones. Basically, drones for good.
The FireDrone project is really relatively complex because the materials that we used are not just readily available. We had to adjust and re-engineer the materials to be structurally lightweight, be structurally sound and strong, and not shrink during heat exposure.
The FireDrone team looked to the animal kingdom for inspiration, studying the thermal regulation abilities of Arctic foxes and penguins.
Penguins, which have black feather coat on their back to absorb radiation from the sun. We somehow took the inverse of it and we applied a coating of aluminum to reflect the heat from the fire.
They even look to spittle bugs, whose foamy fortresses keep them cool.
The components which need to be shielded from the extreme temperatures are all housed within this central aerogel housing. Aerogel are high-performing insulation materials, which are also used in space applications, for example. We have designed the FireDrone this way that it can sustain 200 degrees of environmental temperature for up to 10 minutes.
By withstanding heat, it can give firefighters crucial, life-saving data through CO2 sensors and regular and infrared cameras to help save lives before and after a fire.
The firefighters are the real heroes. They really risk their life and their health to support in fire situations. We need an insight onto the situational awareness at the moment of the fire, but we also need to protect the firefighters and provide tools that can allow them to operate and to do their job with a lower risk.
The FireDrone is still very much a work in progress. But the team has high hopes for its future.
My dream for this technology is that it really takes off, literally, so it scales up and really brings a value, brings a change in the world.